Expressions. An expression is a combination of one or more operators and operands. Arithmetic expressions compute numeric results and make use of the arithmetic operators addition, subtraction, multiplication, division, remainder. If either or both operands are floating point values, then the result is floating point. If both operands to the division operator are integers, the result is an integer. The fractional part is discarded. So for example, if you have 14 divided by 3 and 14 and 3 are declared as integers in Java, then it's going to equal 4. The fractional part gets removed. If you have 8 divided by 12, the 8 is an integer, the 12 is an integer, then the result will be 0. The remainder operator, which is the percent sign, returns the remainder after dividing the first operand by the second operand. So for instance, if you had 14 divided by 3 using the remainder operator, the result is 2 because that's how much you have left over after you divide 3 into 14. 8 divided by 12 does not go into 8 at all, so the remainder of that is 8. So here's a quick check. Okay, so what are the results of the following expressions? Now keep in mind that if something is an integer, there's no fractional part, and if something is a floating point value, then there will be a fractional part. So the first one, we have 12 divided by 2, so the result of that would be 6. We have 12 divided by 2, but they're both floating point values, so the result of that would be 6.0. You have 10 divided by 4, so 4 goes into 10 2.5 times. However, these are integers, so the result of this would be 2. 10 divided by 4, but the 4 is a floating point value, so that means that this entire result is going to be floating point. So this is where you're going to get the 2.5. 4 divided by 10, now both of these are integers, so that means the result of this would be 0. The next one, 4 divided by 10, now since this is a floating point value and this is an integer, the result of this would be a floating point value. The result of this would be 0.4. So this is the interesting one. So 12 divided by 3, but you're looking at the remainder. So 3 actually goes into 12 4 times with no remainder, so the remainder of this would be 0. So the result of this would be 0. 10 divided by 3. 3 goes into 10 3 times with the remainder of 1. So the result of this would be 1. And then 3 divided by 10, but you're looking for the remainder. Since 10 does not go into 3 at all, the remainder of this would be 3. So there are the results, and I believe it's exactly as we expected. Operator precedence. Operators can be combined into larger expressions. So result is equal to total plus count divided by max minus offset. Operators have well-defined precedence which determines the order in which they are evaluated. Multiplication, division, and remainder are evaluated before addition and subtraction and string concatenation. Arithmetic operators with the same precedence are evaluated from left to right. So this is actually kind of important to know because it seems like whenever I give questions about this on the test, a lot of students actually get this wrong, meaning they don't remember you go left or right for operators with the same precedence, such as multiplication and division, but parentheses can be used to force evaluation order. So knowing that we have the order of operations like we do in math in Java, we could come over here and we could determine that this operation will happen first. Count would be divided by max first, and then total and the result of this division will be added, and then offset would be subtracted. So quick check. In what order are the operators evaluated in the following expression? The first one's pretty easy. They're all addition, so you just go from left to right. The next one, multiplication, division take precedence over addition and subtraction. So you're going to multiply B and C, and then you're going to divide D by E, and then you're going to add A to the result of B times C and subtract the result of D divided by E. This next one, parentheses take precedence over division, and this is actually division even though it's the remainder division. So we're going to add B and C first, then we're going to go left or right. So division and the remainder division, they're at the same level, so they both happen at the same time from left to right. So you're going to divide A by the result of B plus C, and then you're going to take D divided by E and find that remainder. Then you're going to subtract the result of this from the result of this. The next one has multiple parentheses nested inside of each other. So we're going to work the innermost parentheses, then work our way to the next one, work our way to the next one. And the last thing we're going to do is we're going to divide A by the result of everything inside the parentheses. And I gave you the order here. The evaluation of a particular expression can be shown using an expression tree. The operators lower in the tree have higher precedence for that expression. What's in the parentheses would be done first, and then you kind of move your way up. Assignments revisited. The assignment operator has lower precedence than arithmetic operators. So here they're giving you answer is equal to sum divided by 4 plus max times lowest. So what they're saying is all this is going to happen first before you assign that to answer. So division happens first, then the multiplication, then you're going to do the addition, and the last thing you'll do is assign the result to answer. the right and left-hand sides of an assignment statement can contain the same variable. So here's something a little interesting in programming. So if you have a value inside of count, let's just say the value of count was 5 before we got to this line. So that value would be used right here for count. So you're going to have that value plus 1. So if it was 5 before this line, then the value 5 plus 1 would be 6, and that would be stored back into count. So then count would be 6 after this line is complete. Increment and decrement. The increment and the decrement operators use only one operand. The statement count plus plus is functionally equivalent to count is equal to count plus 1. So what this does is just basically adds a 1 to count. If you use the decrement, you're going to actually subtract a 1 from count. The increment and decrement operators can be applied postfix form or prefix form. When used as part of a larger expression, the two forms have different effects. Because of their subtleties, the increment and the decrement operators should be used with care. So I do like to ask this on the exams because I want students to understand the difference between the post-increment and decrement and the pre-increment and decrement. And I'll go ahead and give an example of this in a little bit. Assignment operators. Often we perform an operation on a variable and then store the result back into the variable. Java provides assignment operators to simplify this process. For example, num plus equals count is equivalent to num is equal to num plus count. So you can use this form instead of using this form. There are many assignment operators in Java, including the following. So you can use the plus equals, minus equals, multiplication equals, division equals, remainder equals. This is how you would use them, and it's the equivalent to this over here. The right-hand side of an assignment operator can be a complex expression. The entire right-hand expression is evaluated first, then the result is combined with the original variable. Therefore, when you're using result division equals total minus min, remainder with num, it's the equivalent to result is equal to result divided by everything that you had on the other side of this equal sign. Okay, so it's important to know that when you're using this with a complex expression on this side, it's the equivalent of saying figure all this out first, and then you're going to apply this arithmetic operator to the result and whatever you did over here. The behavior of some assignment operators depends on the types of operands. If the operands to the plus equals operator are strings, the assignment operator performs string concatenation. The behavior of an assignment operator plus equals is always consistent with the behavior of the corresponding operator. So this is only applicable to the plus because the plus can be used on a string and it also can be used on primitive data types. So I created a program called Math Operations. The name of my class matches the name of my file. I have the main method, and inside of my main method is where I'm going to put my programming statements. I'm going to demonstrate these arithmetic operators. So I'm going to go ahead and create a few variables, and then I'm going to do some mathematical operations on those variables. Okay, so I created a few variables. I created a string variable to hold my fave num5, but it's holding it as a string. Then I created A, B, and C. A and B are both integers, and then C is a floating point value. Now I forgot to put the F here, so let me do that. And then I have some variables to store some results. And I also want to have a variable for the string result. First example, let's see what happens when we add things to a string. I have a string, and then I'm adding a 5 and a 6 to it. So this is very similar to what we did in the previous lecture, where this is a string, the 5 will be concatenated to it, and then the 6 will be concatenated. I'm going to expect the value 556 whenever I compile and run, and then there's my output, 556. Another thing that I want to do is I want to use fave num plus equals, and we'll say b. So fave num plus equals b, and then I want to print out the result of fave num after I've done this. I'm going to compile, I'm going to run, and you can see that fave num is 56. So b is 6, and fave num is 5 as a string. So essentially what happened is it concatenated the two together. But let's see what happens if I do the same thing with a. So we'll say a plus equals b, and we'll print out the result. So a is 5, b is 6, so the result of this would be 5 plus 6, so I should expect to see an 11, and there's my result, 11. Okay, so now let's see what happens if I try to take result 1, which is an integer, and store a times c. Well, I go to compile, and you can see that I have a compilation error. So what's happening here is c is a floating point value, and result stores a integer, this result variable is not big enough to hold the result of this calculation. This calculation is done as a 32-bit float, but an integer is also 32 bits. Now the reason why this doesn't work is because even though they're both 32 bits, a floating point value that's 32 bits still has more precision because it has fractional parts than an integer that's 32 bits. So Java wants you to fix this, and the way that we're going to fix this is we're going to convert this to a float. Instead of having it as an integer, I'm going to make it a float. So result 1 is now a float. I'm going to compile and run, and then there's the result of A times C. Okay, so I went ahead and created another example so I can demonstrate the rest of the arithmetic operators. So I created a new class called Math Operations 2 as the main method, and I went ahead and created these variables. So what I'm going to do is output the result of these mathematical operations. Okay, so I went ahead and created a whole bunch of examples here. So I have A, which is 2, B, which is 3, and C, which is 4. And actually, I don't use C at any point. But I do an example of addition. I do an example of multiplication. I do an example of subtraction, division. I do a division again, but this time I use B divided by A. And then I do the example of division, but like getting the remainder instead of actually dividing. Now, keep in mind, all these are integers. So when you're using integers, that means you don't have any results with fractions. So I'm expecting A divided by B to just give me a 0 because there's no fractions. And I'm expecting B divided by A to give me a 1 because there's no fractions. So let me go ahead and compile and run. And here are my results. So A plus B is 5, A times C is 6, A minus B, A is 2, B is 3, we get the -1. There's a result of division, there's a result of division, but B divided by A. The remainder, A divided by B, since A is 2 and B is 3, B did not go into A, so the remainder is 2. So B is 3, A is 2, so when you divide 3 by 2, the remainder of that is 1. That's the example of using these arithmetic operators. Okay, so I made another example called Math Operations 3 just to show a complex expression. So I went ahead and reused some of the information here, except I changed the B to a 4 and I set up this expression right here. This is a complex expression. Now it's important to understand this because a lot of students do get this wrong on exams. So it follows the same rules like we do in math, where multiplication and division are done at the same time from left to right. So if multiplication and division are done at the same time from left to right, that means the B is going to be divided before the C. Students seem to think that the C should be multiplied to the A first, and then this will occur. Okay, that's wrong. Multiplication, division are done at the same time from left to right. So knowing that, the result that I'm going to expect is B divided by C. B is 4, C is 4, so I'm expecting this to equate to 1, and then I'm going to multiply that by A. A is 2, so I'm expecting a 2 here, and then A here is 2. So I'm expecting the result of this to be 4. Now, if this did occur first, the C times the A would have resulted in an 8, and then B divided by 8 would have been 4 divided by 8, which is 1/2, right? So that's a fraction. Because these are integers, that would have been a 0, and the result of this would have been a 2. So if I get a 2, that means that this happened first, which it won't, obviously, because Java follows this order of operations just like we do in math. So I'm going to go ahead and compile and run, and you can see that the result of this is a 4. So just keep in mind, when you see something like this, multiplication and division happen at the same time in the order in which they occur from left to right. So this B divided by C will happen before the C being multiplied to the A. Okay, so I created another example called the increment and decrement. The name of my file matches the name of my class. I have my main method, and inside of my main method, I'm going to put my programming statement. So I'm going to go ahead and compile this, make sure I haven't messed up anything yet. So I'm going to go ahead and demonstrate the pre and the postfix increment and decrement so that we can see what it actually does. So the first thing I'm going to do is create a variable, and then I'm going to increment and decrement and output that to the console. So I went ahead and created a variable and I initialized it to 7. Then I printed out that value, and then I went ahead and incremented that value and printed it out again. Then I decremented the value. Decremented means I just subtracted 1 from it, but I did it twice. And then I printed out the value again. So I'm expecting to see a 7, an 8, and then back to a 6. All right, and there's my result, and what happened is exactly as I expected. So the next thing we need to talk about is the pre and the post increment and decrement. I set up another example to demonstrate increment and decrement. This time I'm going to focus on showing you the pre and the post so we can see what that actually does. So I have a variable called count, but this time I have a variable called result where I'm going to store the result of the pre and the post increment and decrement so that I can output it and you can see what the result is. I have result, and I set it equal to count plus plus. Because this is a post increment, Java is not going to change the value of count until after this line is complete. If the current value of count is 7, 7 will be assigned to result, but count would be changed to 8 after this line is complete. So I'm going to go ahead and compile and run and see our results, and you can see that result is 7 and count is 8, and the reason that happened is because the post changes the value of count after the line is complete. So I took the exact same code that I have above, but this time I'm going to do the pre-increment. So I'm going to go ahead and move the plus plus to the front. So keep in mind that count is 8 at this point. So if count is 8 at this point, we're assigning the value of count plus 1 to result. Because I'm using the pre-increment, Java is actually going to change the value of count and store that value into result. So 9 will be stored into result. So whenever you see the pre-increment, that means Java is going to change the value in place. It's almost like if you have parentheses around this and you're performing like the order of operation, you're performing that first before you do anything else. So I'm going to go ahead and compile and run, and you can see the second time I did this, the result is actually 9. So you need to understand the difference between these two. I'll go ahead and set up the same for decrement, and we can see what happens with that. All right, so I basically just copied what I did above and I pasted it here, but this time I just changed this to decrement and decrement. So let's just keep in mind at this point, count is 9. So I'm gonna see the same results where if I'm doing the post decrement, Java is gonna store 9 into result. And then after the line's complete, count is gonna be reduced by 1. So count will be 8 right here, but result would be 9. And then when I get to this point, count is 8. But since I'm doing the pre-decrement, Java is gonna store 7 into result, and count will also be 7 at this point. So both of these here would be 7. So I'm going to compile, run, and there are my results right here.